Okay. YouTube chat, this is EJ Mission Control. Stand by for the event. Hey, Liz, how are you? How's everybody doing? All right, so I am doing this VOD on YouTube to, and I mean on Twitch it is what it is. It probably won't get muted over there. I'm doing this VOD here to watch the Spacex Test As You Fly video. I've seen it, but I haven't really looked at it in detail. To be 100% honest with you, this VOD's probably going to get nuked by the music and stuff. So, let's see what we got. So, on Friday, SpaceX dropped a new video called Test As You Fly. Test As You Fly is actually, we confirmed that Test As You Fly is, here it is right here. It was confirmed on X that Test As You Fly is part of a mini-series, a Starship docu-series, if you will, about Starship development here with all the engineers and people that work on Starship. So, yeah, without further ado, let's jump into it. Are we going to be pausing and pixel peeping? I'm probably just going to watch it first. And then we'll go with there. I haven't seen it with the sound. I was told by people at SpaceX to watch it with the sound on, for what it's worth. So, let's see what we got.
Until about T-minus 4 minutes, a lot of stuff starts going down. T-minus 3 minutes, closing out the propellant load, so you're finishing out the liquid oxygen load and the liquid fuel load. T-minus 40 seconds, we stop interacting with the pad.
Dude.
The vehicle's just on its own.
All right, attention all B-19 operators. This is the final go, no-go poll for today's operations. Our main objective today is a 10-engine static fire.
Why 10 engines instead of all 33? This is the first V3 booster down at the pad right now, so there's a lot of stuff that can go wrong. And if we do have a bad day, it limits the scope of the issues that we can have.
This will be the highest chamber pressure we've ever seen on a vehicle at SpaceX, so definitely going to be a pretty spicy test today.
And then you're counting down from T-minus 40. T-minus 4 on is when my heart rate really starts to tick up. And then we light the engines.
Yeah, baby. That's sick, dude.
Discovery, go at throttle up.
Starbase, baby. Angry Medic, what's up, dude? Oh yeah, the VOD's gonna get nuked by music, absolutely. That's okay though.
We are in Star Factory, and this is an almost 1 million square foot facility that we've...
There's only one time that I'm gonna do this for the initial run. They have Starbase Live on the TV right there. Just pointing it out.
built to enable that production of both ship and booster. Starship is a fully reusable rocket. It's 2 stages, so it has a ship, which is the upper stage, and a booster below it. The booster accelerates the ship to get it going towards orbit. The ship is what actually goes into orbit to take the people or the payload to wherever they're going.
I still can't believe this thing exists, dude. It's just... Hey, MIG welding. Hey, EJ's cousin, if you're still here, there you go, man. MIG welding. Straight up, dude. They're still doing the welds by hand. Some of it is done with automation, but at the end of the day, a guy with a MIG welder and some skill is going to give you a really good result. That's Bill Riley.
Sound of progress.
He runs the Starship
The rivet
program.
guns and the sledgehammers. Less sledgehammers than there used to be. The story of Starship starts with the founding of SpaceX.
3, 2, 1.
Dude, look at the video player. Freaking, was that QuickTime?
Rather than starting with the vehicle that Elon envisioned needing to get people to the moon and Mars, he thought it would basically bankrupt the company. It wouldn't be possible. So you have to bite it off in small pieces.
Start small.
And so those pieces, which at the time did not seem small at all, were Falcon 1, Falcon 9, Dragon, both cargo and crew, Falcon Heavy.
Hey, oh wait.
Falcon Heavy.
Hey,
These
wait
were
a
the
minute,
building
no.
blocks that let us cut
Tomorrow.
our teeth
Or
on learning
whenever.
how to do rockets.
That's spin
Not the way
forming
the
right there.
aerospace industry had been doing it, but the way we needed to do it to end up here where we are today working on Starship.
You know what, dudes? Now that I'm thinking about it, I was going to watch the video unabridged, but I think it might be better to just pause at certain points to look. So that's spin forming. That's how they make Merlin engines. They start with just a flat piece of steel and a mandrel, and they spin it, and then they heat it to conform to the mandrel. The mandrel is nozzle shaped. Yeah, if you want to know how some rocket engines are made, not every one of them is made that way, but how some of them are made, yeah, spin forming. Absolutely a thing. This next thing...
Not the way the aerospace...
This next one here, I'm not 100% sure what's going on with that. If I had to guess, they're probably testing the jackets, the cooling channels. They're called cooling channels in the nozzle. That's I'm pretty sure. Actually, that's a Merlin. No, it's not. That's a Raptor engine. They're probably moving coolant through the cooling jackets. So the nozzle on Raptor has little passageways in it. And they flow propellants through them to keep the nozzle cool. They're probably testing the cooling channels on that one.
Space industry had been
See,
doing.
they got a hose right there, and it's whatever it is, it's moving liquid because of the ball valve right there. See that? So this is a flow test to make sure that the cooling channels work correctly. Oddly similar to how clay plots and jars are made. Yeah, I would like to add that Raptor is not made that way. Merlin engines are spin formed. For simplicity, Raptor is a little bit of a different beast.
But the way we needed
Yeah, see, that's a really old engine, dude. Really old.
to do it to end
That's a
up
Raptor
here
right
where we
there.
are today working on Starship.
It's not cryo. They were just caveman. They were just moving. That was manufacturing coolant, like the coolant that you'd use in a CNC machine. If I was looking at that right. Last two. Is the cooler metal the top? Yeah, in the spin form. Yeah, that was metal that was already formed. Those torches actually just kind of go forward, and the metal ends up conforming, like spinning a clay pot. That's actually a really good way to look at it. So yeah, I think what I'll do is I'll pause every once in a while to talk about what's going on. That'll also, if the VOD by some miraculous chance only gets nuked a little bit, I can trim out different segments, right? Because it's not going to mute when we have it paused because there's no audio playing. So that actually probably would be better in the long run.
Version 3 is what I like to call the foundational design of Starship.
Ooh, we're missing a tile right there. So the pinch part leading to the edge of the nozzle. You're talking about the spincraft thing, right? This VOD this player doesn't like scrubbing around.
Starts with the founding of SpaceX. That Elon seems small. Do rockets. Not the way the aerospace industry had been.
Right here. So this is the part that attaches to the throat, and the mandrel is nozzle shaped like this. And what they do is they heat up the metal. The metal starts as just kind of a big, it looks like a cymbal, like a drum cymbal. Like, if you like drumming, it looks like that. They put it on here. Actually, the funny thing is that cymbals for a drum set is made very similar. It's made in a similar way. Yeah, weird, right? You ever looked at a drum cymbal? Like I have at my drum set, with my drum set, I have zillion ZBT cymbals. If you look at the cymbal, it looks like that. It like spin formed, because that's how cymbals on a drum set are made. Yeah, that's what they start with over there. That's a good point, Granny, right there. So what they do is they heat up the metal, and this whole mechanism here, these are just, if I had to guess, those just look like oxyacetylene roofing torches. And they heat this up, right? And as the metal heats up, it sags into position. It sags onto the mandrel. So the back of the rocket engine would be over here. The combustion chamber would be here, but it's just the nozzle. The nozzle's a subassembly. Is that niobium? Correct. You got to remember. Well, actually, I don't know if that's totally niobium. This is a first stage engine for sure. That's a Merlin 1D first stage, so I'm not 100% on that one.
Not the way the aero.
So those torches just move. They move forward. But the reason why they keep it spinning, Blackness, is because gravity is pushing this way on the mandrel. If you just tried to heat it up and tried to get it to conform, it would sag. So you keep it spinning. You keep it spinning, and it'll slowly conform to that shape. The mandrel is an inverse of the nozzle. Now, keep in mind, that's for the Merlin. Raptor is made differently. The Raptor isn't spin formed. The reason why SpaceX went with a spin forming application for Merlin engines is because it's simple. It's very simple. Raptor, not so much. Raptor has cooling channels. You can see them running coolant. This is industrial machining coolant through the channels here. They're running it into this manifold right there. So how this is working is coolant goes into this manifold, and then it goes through the jackets that go down here to the bottom of the nozzle. They turn around 180 degrees, go back up, and they would come out over here. There would be, on a Raptor engine, there's another manifold right here that looks like this. That's not installed on this just yet. And because it's not installed, they're testing flow through the coolant jackets before that manifold is installed, to make sure that all the cooling channels are not impinged. If you impinge on a cooling channel on a rocket engine like Raptor, it'll blow up. Yep, you'll get non-uniform heating, nozzle burn through, and it'll go right to your thighs, and then you explode. Those cooling channels are made out of copper. They're milled copper cooling channels on a Raptor. Copper is very malleable, so you really have to be careful of impingement, right? Don't like hit it with a hammer. Don't run a drone into it. It's very delicate, which is funny because it's really delicate, but a big explosion comes out the back.
She had been doing it, but the way we needed to do it to end up here where we are today working on Starship.
That was a Merlin engine as well. Are you sure? Yeah, yeah, the throat. You guys are right. The throat is too big for Raptor. So if this is a Merlin engine, you would have the spin formed thing. And huh. I have to, dude, I forgot Merlin's plumbing. I've been teaching people so much about Raptor.
Discovery, go at throttle up.
I totally forgot. That's really kind of sad, actually. Yeah. There it is. Huh. That diagram is potato. Let's go find another one. Yeah, that's great. Good. Nice diagram. See, that's Raptor. That's not right. Time for a refresher. I mean, I know that the Merlin engine is using a gas generator. Okay, so they were testing this one right here. But no, see, that's Raptor again. Are you guys sure? I mean, I don't know. I mean, that's from Tim's video. See, the Merlin engine doesn't have those manifolds, dude. That's like... Yeah, it has one. Yeah, it does. Okay, there it is. But see, they're not... I don't know. Maybe they switched away from spin forming, dude. I don't know. I don't remember. You know who I'd ask? I'd ask Alex about this. Because yeah, that manifold is definitely there, but that top manifold is not. So maybe it's for film cooling or something. I've walked right there, by the way. That's pretty cool. Yeah. Yeah. Interesting. Either way, they're doing it. They're doing the impingement part of the thing is still correct. That's they're testing flow through some kind of channel, but
Had been doing it.
It's very strange because it's coming out over there. It's coming out just downstream of the throat, but I don't know. We'd have to go look. Anyway, let's keep going with the video.
But the way we needed to do it to end up here where we are today working on Starship.
There are no holes for the throat film cooling in the video. Raptor has throat film cooling, and Merlin does have that manifold. Yeah, no, I'm putting two and two together there.
Version 3 is what I like to call the foundational design of Starship booster in the pad. That's going to give us the new capabilities we need to do the missions in front of us. It'll be the one that puts humans back on the moon. It'll be the ones that put the first blueprints and then city on Mars.
Space. Yeah, baby.
Starship is giant, and that scale is not an accident. It's not to win some Guinness World Record prize, which we did for both the ship and the tower. It's because...
You like that painting, chat? Me taking the bull by the horns. It's a metaphor for how I live my life. But that actually happened, you know.
we need that size to do the things we dream of doing with it.
Did you just do that? That's sick, dude. So that's when the booster flipped downwards right there. All right, Dan, see you, buddy. The V3 grid fins are bigger. Hello. I love the generic factory sound effects.
Ship 39 is the first.
Look at that thermal protection system, man. That thing is dialed the frick in, dude. So, guys, if you look at some of the early tile attempts from SpaceX, the tiles are bent. They're all over the place. They're not... They look like badly stacked bricks. Ship 39 has a much more fleshed out system. Like, I don't really have any other way to say this, but if you want your thermal protection system to like, these tiles, they have to be lined up. Like, you can't have a tile that's like this. That is going to impinge hypersonic flow, and yeah, it's going to make a hotspot. The tiles have to be like think a Roman phalanx. It has to be, if you like, you know, antiquity siege warfare, I guess, like a Roman phalanx, they have to be like butted up against to each other correctly. If there's one chink in the armor, so to speak, it's not going to work. You're going to get burned through. The tiles almost have to look like a shiny one-piece finish, like that. That's how it should look. I wonder why they didn't use tongue and groove. It's because of the thermal expansion on the tiles. That's why they have the gap filler here, because the tiles do expand and contract. During re-entry, the adhesion mechanism, so the stainless steel is going to expand, and the tiles are going to expand, and when they expand, they have to butt up against each other correctly. The gap filler is designed to seal in case you get some weird deformation. Yeah, see how this is making a sheen right there? Like, it looks like one thing, like this is a painted texture on a surface. That's what you want it to look like. That's right. The only reason I know this is because of the shuttle, like, because I spent too much time reading about that thing. The only way these things work is if plasma can flow over this like it's one thing. If plasma, like it's one contiguous thing. If there's even a little, like, if one tile is even a little like offset to the other, you're going to make a hot spot and it will burn through.
V3 rocket. This rocket is...
See that? See how it looks like... It looks like they painted hexagons onto the vehicle. Instead of a bunch of individual tiles, it looks like one contiguous thing. That's a thermal protection system. That's how you make that work. You see how it's shining off the lights? And how you don't see any deformation in the sheen right there? It's just one continuous thing. That's how it should look. That's impressive, dude. That's a thermal protection system. That'll work. The shuttle had to do the same thing, Joe. The shuttle actually had to do it even more. The shuttle, they didn't even have gap filler because the silicate, they shimmed the tiles. They shimmed them and then they took the shims out. They didn't have gap filler. With the shuttle, because it was made out of aluminum, the aluminum expanded and the tiles expanded and they just butted up against each other. Yeah, yeah, thermal expansion. Turns out when you dump a bunch of heat energy into anything, it expands. Do they flex the tiles? Yes. That's why they have a silica-based gap filler. That's what those white lines are. It's kind of like a fire blanket almost. And that fire blanket is soft. It's malleable. Well, not malleable. It's like cloth almost. So the tiles can expand and the gap filler will fill in any weird, like, no parts. There are also parts that are glued. Tile parts that are glued together, but the vast majority of this is using the gap filler with the crunch wrap. They call it a crunch wrap. Because if you put the tile with the gap filler around it, it looks like a crunch wrap supreme from Taco Bell. Props to the TPS techs. Imagine placing those one by one for 12 hours every day. Yep. In boat building, the process of smoothing out the hull is called fairing. To see if the hull is fair, it means smooth. Yeah, Riv, it's not exactly like that, but yeah, that's the idea. the best way I can describe it is that if it's shiny, if you have some sheen, or if you speak 3D model or some specularity from your thermal protection system, that's how you know that's how you know it works. This is the fourth time I'm watching it. It gets more and more excited every time you see it. Yep. What's the second heat shield that's underneath the tile? That's silica. That's the silica backing. The crunch wrap is the second heat shield behind it. Why exactly tiles? Could this be painted? Code Keo, here's the thing about thermal protection systems. With thermal protection systems, you need a system that can withstand 1600 C. Actually, in the case of Starship, because it's returning from the moon and Mars, it's more than that. It's more like 2000 Celsius, like 5,000 Fahrenheit. It's something ridiculous, dude. You need something that can do that. Now, is there things that can do that out there? Yeah, of course, dude. Yeah, of course. Plenty of things that can withstand that. Like Crucible from a steel mill would be able to handle that, no problem. But it's also got to be low mass. It's got to be light. That's why they use the tiles. That's why the shuttle used the tiles. That's why Orion has tiles. That's why Starship has tiles. The tiles can simultaneously tank an incredible amount of heat. They are actually, by definition, a heat sink. You can put crazy amounts of heat into them before they start, bad stuff starts to happen, right? And they're also super light. They're low mass. Are there other ways to make a heat shield? Yes. Are there things that will be able to withstand 2000 Celsius? Yes, absolutely. But not every, remember, the name of the game with this thing is low mass. It has to be low mass. The tiles are absurdly light. How do I know? That probably is a dead giveaway. This thing is very light, about the consistency of styrofoam. How fast do you think they could refurbish the first ship? Don't know. Max, use some logical extrapolation here. They want to be able to launch this every hour, so I'm going to guess that it's not about how fast you're going to be able to do it, right? It's about getting it done in an hour if it needs it.
Unlike
Is it
anything
itchy?
anybody's
No.
ever done before. Version 3 is basically a clean sheet design of the ship.
Chalet.
We essentially took a bunch of lessons from version 1 and version
Dude, Alex and I were looking at this on Flame Trench. They have some, this is the common dome on Starship. So there's your transfer tube right there. That goes to the forward
Discovery,
header
go at
tanks.
throttle up.
And then their pickup right here at the bottom of the methane tank looks like a beehive. The reason why it looks like a beehive like this, or like a death ray from like a 1950s pulp sci-fi thing, is these are stringers right here. Those are designed to limit deformation here. The interesting thing is that this center beehive thing feeds the 3 inner engines on Starship. And if you look at the outer ones here, they have external well, not external downcomers. Those are internal downcomers right there. And those 3 go to the vacuum engines. So the top of the ship is over here. Scratch that. The bottom of the ship is over here. Top of the transfer tube goes on the top now? Wait a minute. That's backwards. They must have changed that. I don't remember the transfer tubes doing that. The transfer tube should be down here, no? It's on the top after the V2 ship. Huh. Are you sure, Liz? I don't ever remember that. But then again, people tank watch a lot more than I do. That means their transfer tube has to go through the top of the methane tank and then go down over it and then through the pit. Huh. Because, so fellas, this is the tube that goes to the forward tanks on Starship. Starship has 2 what's called header tanks up in the nose. And those tanks are designed for landing. It's designed for landing the ship. The reason why they use more like smaller tanks up at the nose of the ship is for balance during that flip and burn. And the transfer tube right there, this is the header tank line, is what connects to them. Oh, you know what? I see what's going on here. This is the oxygen transfer line. The oxygen transfer line is going to go through here and pick up with the methane transfer tube line over here. And they're probably running side by side through the belly of the ship around, because you got to go around the payload bay. The fuel tanks are up at the front in the nose of Starship, right? You can see them when they were integrating one here a second ago. See the tubes? Here, just play. Look. That's not a transfer tube. It's the header tank line, dude. See them right there? 2 lines, 1 and 2. There's your header tanks up in the nose of the vehicle. And it looks like they have a truss brace to hold them in position to make sure they don't move around. I mean, having fuel tanks up there probably. Yeah, Mutter, that's what I was thinking. That's the door side, dude. There's a payload bay door in the way. But they probably kept so that's the liquid oxygen transfer line to the header tanks there. Oh. Bro, look at that. Wonder where they put the header tank for the Artemis 3 docking. So, Lunar Lander, the Starship HLS, the lander variant, doesn't have header tanks because it doesn't come back down and land on Earth. On Earth, on the moon, you don't need to do a flip and burn. You don't need to do that. That's just for starships that come back down. HLS, once it's up there, it stays up there. See, that's interesting because this one doesn't... Oh, no, it's over there. I was going to say, that one doesn't seem to have it, but...
And we took a step back and...
See there? Oh, see, there's the double transfer tubes right there. But they're on the wrong side again. They must elbow down through and... I don't know, we'll keep watching.
What were the things that were really problematic, either from a performance perspective or from a reliability perspective on the previous rockets? And then we directly addressed those with a variety of new designs.
See how uniform all those tiles are? It looks like they painted the texture on there. That's real good. Real good. Man, see, hold up. I'm seeing some weirdness on the flap. See those? There is a little bit of funkiness on the flap over there. See that gap right there? Yeah. And right there. Got to be careful with that. That's gonna cause a hot spot. I can tell you that with absolute confidence. And it looks like where the circular part here, the pivoting point of the flap connects to the actual flap aero surface. I'm seeing some gappage over there. Some non-uniform tiles all up in there. But maybe they addressed it. Maybe this is old.
It can go up to orbit, it can stay on orbit for 48 hours, it can meet up with other ships, and it can do propellant transfers, which is really the core technology that you need to unlock Starship. Once you unlock that capability, the whole solar system is on your doorstep.
See, there's your header tank transfer lines right there. They are, so Mutter, look, they are bending down. See, the reason why I was wondering about that is because Starship has the payload bay, and you don't want fuel lines going through your payload bay, like directly through the center. The lines are on one side, but if you look, they're not elbowed, they're bent. They're going this way because they're going to elbow down there and go this way. You keep them on the bottom of the payload bay, so to speak, right? Because the payload bay dispenser is over here.
And right now what we're doing is we're actually going through checkouts. So we're actually kind of bringing the rocket to life.
Yeah, spoiled. That's a good point. They want to prevent hydraulic hammering. That makes sense. Dude, look at this. Look at this facility. This is a facility where people are building freaking spaceships. Just, like, I always try to pause and remember I was talking about if you've been watching the stream all day, I was talking about just like sit back and think about what's going on here. Like me, I sit back and think about like a dump truck going by. I'm like, dude, that thing's sick. Dump truck's awesome. It can move crazy amounts of stuff. Like, look at this picture. This is a building where spacecraft are being built en masse. Not like a small spacecraft either. This is a facility to build gigantic freaking spaceships. You know, like, this looks like something out of sci-fi, dude. Look at, like, they're building spaceships, dude. That's what happens. This is, I believe this is Mega Bay 2 for ships, Mega Bay 1 for boosters. Like, look, there's just another, see, look, there's another office chair down there. See, that's how you know they're doing it right, when you have just office chairs just sitting down there. Like, can you imagine? That's just a desk chair and a desk. That's somebody's office. Somebody goes to work and works here. Like, that's somebody's office. There's a toolbox right there. You're doing work on this part of Starship. Whatever. Gigabay is going to be even crazier, dude. Gigabay is going to be rows of this. They can only fit so many ships in Mega Bay 2. There's only so many processing stools, I call them. They're transport stands. Look. Look. Must be on a shift change because there's nobody around. But see the person just peeking out the door over there? Whatever. Just building 2 ships. Now, tank watchers, which ships are this? That's 39 and 40, right? Bro. Look, just... This is why I wanted to go over this with you guys. Look at this. Look at this picture. It's just building spaceships. Is this live? The stream is live. This is a video that SpaceX released on Friday, friendly. But yeah, I'm here. Hello. But see the dispenser right there? That's what I was wondering about with the transfer lines. The transfer lines are right here, but they can't go this way to the header tanks, which are up here, because there's the dispenser in the way. Would you just look at it? Would you just look? Owl, would you look at this? Oh, dude, this is ridiculous, man. It's ridiculous. Like, look at how big Starship is. It's freaking gigantic. Like, I've seen these things up close, but this shot actually does kind of drive it home a little bit. This is freaking huge. Check your earlier message. What's on your mind? You should see the facilities in Hawthorne. I've been through Hawthorne, but I have not been through Hawthorne recently. I don't see your last, Liz. If it's not a tag for me, I don't. It becomes infinitely more difficult to find. Oh, you want to post the link? Yeah, here. Yeah, I got it. Post away, my friend. Would you work there if offered? Yes. There's very few jobs that would keep me from leaving this job. And I'd probably still stream on the side. I just wouldn't be able to do it as much. Scroll down. You don't tell me what to do. Oh, this is Ring Watchers. Yeah. Yeah, I see it. There's a lot of scrolling here. I'll have to read that later.
I've never built a ship V3 before and gotten it to this state of production.
SpaceX NDA may prevent you from streaming. It's possible.
So we are going to have special things to this specific vehicle that are going to be odd, but there's also things about the architecture as a whole that we don't really know how to deal with because we've only done simulations, we've only built fluid models of how we think a ship V3 operates. Now we have the real deal next to us.
First priority is your safety. The second priority is make sure the vehicle's okay.
Dude, look at the payload dispenser. It's freaking gigantic. You don't, you know, watching Starbase Live and stuff, you don't really... You don't really kind of put two and two together here. Yeah, see, they got HVAC. They're putting positive pressure in here. So if you're putting positive pressure in there, that means somebody's doing something that makes gas. So someone's probably welding in there. Like, just look at the scale. That thing launches into space, dude. And it comes back down. Yeah, there is a COPV over there. And then there's your transfer lines right there. See them? One of them's behind the rope. See the transfer lines? And then those are composite overwrap pressure vessels. Think of them like scuba tanks that are wrapped in carbon fiber. They're used for pneumatic pressure. In this particular case, nitrogen. This is the PEZ dispenser right here. These truss sections going across there.
And then we worry about executing to our schedule.
We're quite excited, we're quite anxious, but all things considered, we're pretty well
That hat is sick. I like that hat a lot.
prepared. We think that we'll have a good result.
So, see these two things? These little nodule thingamajiggers that are coming out the top here? That's the docking mechanism, or at least that's the shell for the docking mechanism. The starships are going to have 4 posts, two at the bottom, 2 at the top, and they're going to come together. And that's where you'll be able to dock the things together. So they can do prop transfer like what they were telling about. Oh, Starship is using Z-up orientation. So see, it says PY right there on the lifting bracket. Positive Y-axis, meaning X is forward and back. Z is this way, right? And Y is left to right, support and starboard. So they're using Z-up. As they should. Y-up fanboys for the win. So port side is positive Y-axis. Starboard side is negative Y. The nose of the ship is positive X. The tails, the engines are negative X. And then positive Z is the way the letter opener and the docking mechanism is oriented. And then negative Z is the thermal protection system. X and Z could be flipped. I highly, highly doubt that they would do that way, Mutter. But yeah, you might be right. I'm going to go ahead and guess that SpaceX isn't that completely unhinged. You know what I mean? I'm going to go ahead and guess that they're not that unhinged. But they might be that unhinged. Who knows? Click.
We intentionally started Starship with the ship portion because it was so novel. We have done a reusable booster before with Falcon 9, and so it's at least a little bit better tread ground. I will say, I think the booster turned out to be a lot harder than we gave it credit for.
Yeah. The booster, or in Spanish, el booster. I don't know how to say that in Spanish. Hello.
This is an entirely new rocket. This is the most ambitious vehicle designed.
Le booster would be French. Il booster would be Italian, right? Right? That's how that works.
And I have ever personally worked on, and it is a wild thing to see come to reality.
Hello. So this is Mega Bay 1, and there's a mustache on the gantry crane for some reason. But, you know, whatever. We won't read too much into that. This is Mega Bay 1, and that's where they put the boosters together. La Boostra. Viasat 3 is now net April 29th at 10:06. Crap. I can't make that. I have a dentist appointment. I'll see if I can reschedule.
The version 1 flight test campaign really exemplifies the rapid integrated test style.
So that's a really old booster right there. That's booster 4, I believe, because booster 4 only had 9 engines in the center. Yeah, see, there's a ring of 8 and 1 in the center. Now there's a ring of 10 on the newer boosters and 3 in the center. That's a really old picture. And by really old, I mean like what? What's really old here for booster 4 being on OLM1? Neither of these things exist. Well, kind of. Neither. This pad doesn't exist anymore. This is like what, 2022? 2023?
That we do in SpaceX engineering. It took us 5 flights from our first attempt, from flight 1 to flight 5, to successfully catch a booster, which was honestly mind-blowing. Flight 1 was able to get off the pad successfully. It proved that we could get this full system together, and we learned a lot from the eventual failure of the vehicle in that flight. We were able to put...
Yeah. Yeah, it didn't work. But they figured it out, you know. Yeah.
Together a lot of improvements on the launch pad.
That's the shower head.
And on the vehicle hardware design that led to much better success in Flight 2. We were able to make it with the booster to MECO. We were able to separate the ship, and we were able to begin boosting back towards the launch site. So we hit the next big milestone in the flight test campaign. On Flight 3, we were able to get all the way through our boost back burn. On Flight 4, we were able to do a successful water landing demonstration. And on Flight 5, we were able to come back to our launch site and successfully catch the vehicle with our chopsticks. To be able to go fly.
I still can't believe that happened, but whatever.
Fly that and have complete mission success at that point of we got the payload to orbit and we landed that rocket was incredible. I'm getting goosebumps talking about it now.
For real.
Discovery, go at throttle up.
Oh no! 70 months. What's up, dude?
We're about to get into a really exciting period of the vehicle test campaign here, putting the thing through its paces and making sure that everything we designed works okay.
NSF truck in this picture? Question? Gage is probably out there. I think that's Gage's truck right there. Cool.
Right here?
Think that's a big bolt? How big's the, also, is that a Milwaukee? It's a Milwaukee M18. All right, nice. Look at the size of that socket. It's pretty big.
To get all of the pieces of the system working together for the first time, and if we're going to learn anything from that, we'll learn it as quickly as we possibly
can. Yeah, they learned something quick from Booster 18.
can. Booster 19 is actually the second of the version 3 boosters that we've built. Booster 18 came before it. We had an unfortunate anomaly during our first test campaign of the Booster 18 vehicle. This is the first version 3 booster that we've built, so this is Booster 18. This is really awesome because it's going to be our first full vehicle level operation and test with a version 3 vehicle. So
Thanks
the
for
whole team's
gifting
very
10,
excited
man.
about this.
Appreciate you.
Oh,
Sure
this is
hope
space.
it works.
I'm in space.
Sure hope it works. Yeah.
When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
So when they're testing boosters with no rocket engines, and they fill them up with nitrogen, either for nitrogen gas or liquid nitrogen for testing. Liquid nitrogen is a good analog, and nitrogen is inert. It doesn't it doesn't go boom. It'll just pop because of pressure, but it doesn't explode. So one of the composite overwrap pressure vessels on the booster popped there. So inside of these kind of fins, they're called chines on Super Heavy, there are pressure vessels in there. Once again, it's more of those scuba tank things that I was telling you guys about. A composite overwrap pressure vessel is like a titanium pressure vessel that's wrapped in carbon fiber. The idea is that you can store gases at insanely high pressure. You can get a lot of gas in a very small space because space is limited on a booster, right? Well, even a big booster this big, space is limited usually on a spacecraft. So if you can get more into less space, the better. One of them popped and blew a big hole in the side of the booster. 1231. Gotta refresh.
The rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
The fact that that thing didn't tip over is pretty impressive, because the transfer tube in the center, there's a pipe that goes from the bottom of the vehicle, and that, I say a pipe, that pipe is as wide as a Falcon 9. It's almost as wide as some of those tanks back there. That goes from the engine section of the vehicle up to the methane tank. You can see it right there. That's what's holding up the top of the booster, because the outside is definitely not, because it's not alive right now. The fact that that didn't fall over is pretty impressive. Is nitrogen as volatile as hydrogen? No, not at all. Nitrogen's inert. It is reactive, but, well, not really. It can absorb heat, and that's about it. Nitrogen for cryoproofing is also a good idea because it helps you find leaks in the methane tanks. Yeah. It's good, Tanit, because it's similar. Nitrogen is a similar size to oxygen, so it's good for testing. Yeah, nitrogen reacts at high temperatures, exactly. If you're using cryogenic nitrogen, it's mostly inert. You're good to go. How easy will it be to make nitrogen on the moon? I'm sure we could figure out a way to do it, Mustard Goon, but the booster, I would like to point out that the booster doesn't really use nitrogen for its propellants. It's using liquid methane and liquid oxygen. So you have two tanks on the booster. This one is liquid oxygen down here, and see that ridge right there? That's the gap that holds the thing together. And then there's a liquid methane tank up here. They do use nitrogen for this part of the booster. And the reason why they do is for spin starting the engines. To get Raptors to start, they introduce compressed nitrogen into the turbines, and that's what gets them spinning. Yeah, that is only on the booster. This part doesn't go beyond Earth, so you don't need to worry about making nitrogen for this. But with Starship, you might have some other you're gonna have to figure out a way to make nitrogen somehow up there. I'm sure they could figure it out. Like, dude, if you can do something like this, you could probably figure it out. But yeah. Chines, not shines. Chines with a C. Or you could call them strakes. They don't, SpaceX just calls them, I don't know what they call them. They said chines in one of Tim's videos, so I guess that's the way to call it. That's what you should call it. Could they run the cold gas system off CO2? Yeah, but your CO2 is reactive, so I wouldn't do that. I wouldn't introduce any more oxygen into your engines than you need to. Hey, Dodo, tier 2, 125 months. Thank you. Hello. What's up, Jenna?
Yeah, as part of testing, this is loud, so you learn to not be super skittish as you're walking around. So we have our booster here on site. We're going to be performing a cryo proof. It's actually a really long day, so it's nominally planned to be a 12-hour overall prop load and offload. It's just a ton of propellant that we're putting on the vehicle, and we do a bunch of test cases throughout the whole day. So it's a long one.
I don't know, Bauxy. Let's watch it and find out.
Taking booster SM to cryo high fill proof.
Cryoproof is the first time you actually put propellant onto the vehicle. The liquid propellant that we're putting on, it does get pretty cold, generally in the 80 Kelvin range. We want to test like you fly and fly like you test.
No on 70% proof percentage. Stay firm. And fuel interface is fully cryo now.
There is definitely nothing like a late night with your team in the control room. It's one of those milestones where you're like, wow, if I can load a rocket, this is amazing.
They depress the tanks and all the ice comes off. So what happens when you, for the people that don't know, just in case you're watching this, when you fill up a vehicle with cryogenic propellants, so cold propellants, ice tends to form on the outside. Now, why? Okay, why are they using cold propellants first? We'll tackle that one. They're using cold propellants because it's easy. If the propellant is cold, it's easier to get more of it in there. The other thing is that they're using liquid methane and liquid oxygen. Now, if you think about oxygen and methane, just like if you'd encounter them down here on Earth, they'd be gases, right? They kind of naturally are gases down here. You're breathing oxygen and nitrogen right now. You think that's air you're breathing now. So in order to get those gases to become liquids, you need to freeze them. That's so the propellants are very cold. In rocket science, they're called cryogenic commodities. Commodities are anything you need to fill onto the booster to get it to get off the pad. And so what happens is when you fill up the booster, even in a cryoproof test with these cryogenic commodities, it's the same type of phenomenon. Like if you take a cold snack or beverage out of the refrigerator on a hot summer day, you get, it sweats a little bit, you get condensation. What's going on is the atmosphere is getting close. The atmosphere that's around the booster, right? It's encountering that cold stuff because the atmosphere is gas. It actually ends up changing phase, right? It actually freezes the water vapor, the humidity in the atmosphere. And that's what gives you that ice that's on the sides of the booster. Condensation. It's basically freezing parts of the atmosphere up against the sides of the booster. That's why you get a lot of ice. Now you have to explain matter states. No. No, I don't want to.
Let's go ahead and get.
That's why the booster is big ice. Big ice around the entire booster. That's why it looks white. McGregor, Texas, the rocket development facility. I remember this from Friday. You're gonna want to pay attention to this. In order for the gases to become liquid, you have to freeze them. Doesn't stuff become solid when you freeze it versus liquid? That's a good question, Friendly. Yes, eventually. Eventually stuff can solidify. Yeah, eventually it'll solidify. The key is to don't cool it that far. SpaceX has, in the past with Falcon 9, they've cooled it a little too far and the rocket blew up. The Almost 6 launch with SpaceX, they had solid oxygen permeation problems because they cooled the propellants too much. Yeah, our Falcon 9 exploded with a payload on top of it. So, yeah, dude. But to get gas to condense into liquid, you have to freeze it. If you want to, it depends, dude. Like, here's the thing. So, like, let's take water. Water is 2 hydrogens and an oxygen, right? H2O, right? Water will exist as a liquid between 0 Celsius and 100 Celsius. Past 100 Celsius, it turns to gas, right? You go below 0 Celsius, it turns to ice, right? It'll solidify. Every element can do that to an extent. I mean, some of them it's harder to do with others. Every element that you see on the periodic table can do that. To, like, whether we can do it here is kind of another question. Like, you can't, but some of the windows for solidification for certain elements is very, very small. Like, let's take hydrogen, for instance. Could you solidify hydrogen? Yes, but you'd need to do it under very, very specific circumstances to get hydrogen to solidify into a solid. It's doable. It's just not doable for a rocket. We don't... The reason why is because hydrogen for most of, like basically all ranges and temperatures exists as a gas for the most part. There is a very narrow window near absolute zero, like that's maybe 4 to 5 Kelvin, where it exists as a liquid. And then there's an even smaller window where it exists as a solid, and then you hit absolute zero. And yeah, it's tough to do that before you hit absolute zero. That's hard to do. Let me put it that way. So, like, every single element has kind of temperatures where it will turn into gas or turn into a solid or turn into a liquid. You can do that with pretty much anything. Like mercury, for instance. Mercury in our atmosphere at 1 bar at, let's say 20 degrees Celsius will be, it's liquid. It's liquid at room temperature and earth pressure. Could you get mercury to solidify? Yeah, sure, of course. Could you get it to turn to gas? Yes, absolutely. So yeah, we're going back to like middle school science here, but yeah, everything can change phase. Some of them are just harder to do than others. But yeah, that was a good question, dude. How do you cool them? Okay. Think about it for a second. How do you cool anything? You put, say you put a microwave dinner in the refrigerator. What happens? It gets cold. What does a refrigerator do? A refrigerator pulls heat. It pulls heat energy out of stuff through phase change of gases. So how does an air conditioner work in a car? An air conditioner has a condenser and evaporator, and it uses phase change in the ideal gas law to be able to change temperature. Actually, it's taking, if you really, really, really want to know what an air conditioner does, is actually takes humidity out of the atmosphere, not really necessarily heat, but that's another story. I love refrigerators. So how do you cool things? Well, you want to cool anything, you got to take the heat out of it. There are ways to change the temperature, though. If you remove humidity, right? If you remove the humidity, that's less stuff that heat can enter into, which is why air conditioners remove humidity and not necessarily take out heat. Because if you have our atmosphere with high humidity in it, the water vapor in the atmosphere, more heat can enter into that because water absorbs heat really, really well. And that's why if you live in the South, right? If you live in like Florida, that's why when you go outside, it's oppressively freaking hot because the water vapor in the atmosphere is carrying heat along with the air. If you remove that, you have an atmosphere. If you take the water vapor out of the atmosphere and go to lower humidity, right, it can feel a lot better because there's less things in the atmosphere to absorb heat. How do you cool things? You take heat away from them. Remember, temperature isn't this thing that we invented just because how we feel, right? I mean, I would argue that that's what Fahrenheit is, but whatever. Temperature is there scientifically. So if we're using Kelvin, right? All that does is measure the amount of heat energy in a thing. That's all it does. Temperatures that we use here, Celsius and Fahrenheit, those are just a measurement of how much heat is in the atmosphere, for instance. Yeah, that's the other reason, if you're wondering, like low humidity, that's why the desert gets really freaking cold at night. But yeah, that's those are good questions, guys. Good questions. Yeah, how do you get something to change phase? Take the energy out of it. Or in the case of humans, in like an air conditioner in your house or car, take the humidity out. Don't remind me it's about to get oppressively humid again. Yeah, that's where that whole phrase like, oh, it's a dry heat. It's a dry heat. Because 100 degrees at 5% humidity does not feel like, so 100 degrees Fahrenheit, not Celsius. You'd feel that. 100 Fahrenheit, which is, I think it's like 40 C or something. 40 C at like 5% humidity feels very different to 40 C at 100% humidity. Kelvin is a molecular energy. Yeah, I'm just trying to do surface level stuff, dude. I'm trying not to break people's brains too much, okay? Test stand. Hello. So these are rocket testing stands. This one is a Raptor 3 test stand. This is where you fire the thing to make sure that it works. It's a dry heat. Well, yeah, so is my oven, but you don't see me sticking my head in there. Yeah, yeah, right. Oh, it's a dry heat. Oh, yeah, sure. Cope. That's a Raptor 3 engine right there. Yeet! So on your test stand here, if we back it out, you have a couple of different things going on.
This is space. I'm in space.
Hey. Hibbit gifted us, Nova gifted a sub to Hibbit. Yeah, there you go. I'm watching the beginning of your VOD. Spin forming uses a mandrel, but it also uses a forming tool that pushes the material against the mandrel. It's not formed by gravity alone. Yeah, I know, Dean. Yeah, I got it. When I said the thing pushes it, that's what I was getting at. I probably didn't explain it well enough, but yes, you're right. So you have your you have your liquid methane and your liquid oxygen tank here, and they feed into the engine, into the test stand. You might have additional tanks here to do longer duration tests. I'm not sure which one is which, but yeah, that's all the test stand does. It's basically, it's the engine with no rocket attached to it. It's just the tank farm attached to the rocket engine. Now, the launch pad would be the tank farm attached to the rocket, which has the engine attached to it. This is taking a little bit of this is simplifying the equation, so to speak. That's what test stands do. So you can get good data on the engine and the engine by itself, and not introduce more complication just to test your engines. Sick. Grasshopper. Yeah, there are also water tanks to make sure that you don't burn a hole into the ground, too. They were using KSP sound effects for that engine? What? No way. I don't think so. That's an old Raptor startup? Well, that was a Raptor 3. Yep. It was a trick to watch it again, most likely. Ooh. So, interesting. Low throttle. No, the Raptor 3s don't have a bark anymore, Jack, which is a shame. It's just kind of, and that's about it. You don't agree that it's mainly a humidity exchange. It's really not up for debate, Tenet. Like, that's what an air conditioner does. Like, I don't really, it's not like, well, I don't think it does. Yeah, no, that's what it does. An air conditioner removes humidity. Like, I mean, like, I don't know what else you want to hear. Like, an air conditioner is a combination of a heat pump and a dehumidifier. Yeah, I know. That's why, yeah, that last part, the dehumidifier part, guys. Yeah, I know. The dehumidifier part. What does that do? What is a dehumidifier? Oh, it takes humidity out of things. Like, why are we splitting hairs here? Watch this.
Oh. This is a Raptor 3. V3 is a high...
Can I just... Holy crap, dude. That's nice.
Performance.
I'd like to spend some time in this room.
It's also designed to be reusable and highly reliable.
Kind of jelly of Jacob's job, I'm not gonna lie.
We've learned a lot over the course of producing around 600 V2 engines. You can see the amount of simplification that's occurred between V2 and V3.
That's crazy, dude. You know they lined him up just for that shot. Well, yeah, of course. Jeepers creepers, dude. So the reason why Raptor 3 appears to be more simplified, I mean, it is, don't get me wrong, it is because they optimized Raptor 3 to be more manufacturable. That's why they simplified it so much. Because all these little lines and stuff, all that stuff takes time to put together. SpaceX doesn't have time. SpaceX doesn't do slow, right? So they made the engine much easier to put together and manufacture. All this stuff is all integrated into these components. And there are benefits of doing all of that. The benefit is that the engine can be more powerful. But it's not without its detractors either. If something is easier to manufacture, de facto, it's probably harder to take apart. So Raptor engines are, you can take it apart, but if something does go wrong with an engine and you need to replace it, that's exactly what you're going to do. Take the damn thing off and put another one on, and then send that thing back to the factory to get it to be rebuilt or something, or just part it out. Simplifying all your plumbing on the rocket engine is going to make the engine harder to maintain. But the idea is that because you put it together, right, you can put it together a lot easier, right, that you can make a lot of them. So you don't need to maintain them. You can, if one breaks, all right, take it off. Take it apart, use the parts for other rocket engines. Think about Raptor 2 being like a desktop PC and Raptor 3 being a laptop. Could you take apart a laptop? Sure. Is it harder to do than taking apart a desktop PC? Yeah. That's a good way to say that, Curtex. The idea is that because the motor is easier to manufacture, you can make a lot of them. So if something does go wrong, it's not going to knock out, like, it's not going to knock out like an entire launch campaign, right? Because think about it. SpaceX needs to, we're talking about like 10 to 15 refueling flights here for Starship. That's 10 to 15 super heavies that have to work absolutely. And if something does go weird, right, those 10 to 15 flights have to happen on a rather expedient schedule because propellants, right? The propellants are cold. Long story short, propellants are cold in space. Sitting in the sun in space makes the propellants not cold. That's a problem. So these missions have to get done relatively quick, right? So if something does go wonky with a super heavy, you just swap an engine out. Send the engine back to the factory. The idea with a greater pool of engines that you can pull from, if something does go wrong with a motor and you need to replace it, fine, take it off, put another one on. How are they going to deal with warping of the Raptor nozzle on booster reentry? Raptor 3s have that thermal protection system built into them from the start, Max. It's one of the things that SpaceX has talked about. They integrated the TPS for the booster. The thermal protection system for the booster is integrated into the engines. Yep. That's the other reason why Raptor 3 has this look at it. It's made out of, I'm not going to say that because it's darker. The darker stuff is the thermal protection system, but they definitely made this thing a little more beefy to be able to withstand the heat.
Occurred between V2 and V3.
Dude, look at that. It's so simple. That's so cool, dude.
The level of integration is really unique for rocket.
Billet. So these two, this gusset right there and there is for your thrust vector control. That's where it attaches. There's two of them clocked at 12 and 3, right? The idea is that this one makes the engine move this way, and this one makes the engine move that way. With 2 axes of control, the engine can turn in any direction. That's what those things are for. Look at how beefy that is. That's probably about 1 inch thick, so about 25 to 30, yeah, I'd say about 26 mil. That's thick. That's thick freaking metal. Yeah, the welds are all perfect here. That's beautiful. Beautiful welds. And that definitely, they look to be hand done, Spoon, from what I can tell. Like, you can definitely tell where they, I don't know. I was going to say, that doesn't look like a machine did it, but it may have.
Rocket engine, that comes from a lot of work among many engineers to consolidate the hardware. The effect.
Bro, did you see that? What is that bolt torque down to? And he's using a chicken foot? Dude, that is a beefy freaking wrench. Actually, is it a torque wrench? I don't know. It looks like a breaker bar. Wow. Dude, what the heck is that thing torqued to? I'll bet you it's up there, dude. I do not have a... Dude, that is an inch... That is an inch drive torque wrench. I definitely do not have that. It's torque to Gutentheit. Yeah. German spec. Do we have the stretch goal for a bigger wrench? Bro, that's a half inch. It's a half, or no, that's a full inch drive, Dodo. That's 26 mil drive right there. I don't think I need that for anything unless we're working on some serious off-road stuff. That's ridiculous, dude. That wrench is beefy. That's an expensive socket drive.
The effect of that is that it's actually a higher reliability design. So fewer parts is cheaper.
Yeah, we'd need that for working on tanks and like heavy duty trucks and stuff, man.
Faster to build.
I don't know. I'll ask Rob. How much is? Do you have an inch torque wrench? Jesus.
Overhaul, just build a better rocket.
Yeah, baby.
Achieving full reusability of an engine like this is really something that people haven't done
I still can't
before.
believe they can do that.
The goal is to get the engine to behave in a similar way to the engines on commercial airplanes.
Come on now.
Frequently in interactions with people outside of SpaceX, the perception is that things far beyond what have ever been done before are impossible. Things being impossible is really to be determined by breaking laws of physics.
Wow. That's impressive, dude. They killed that drone more like they killed that motor. Just saying.
We are not breaking laws of physics. We're just trying to leverage them as effectively as we can.
Yeah, baby. That's what it's about, dude. Did you hear what Jacob just said right there? Listen to what he says. I'll shut up for a second.
Physics, we're just trying to leverage them as effectively as we can.
That's a good way to think about it. You know, you think that, you know, you have to, the laws of physics are there to, as a bounding box. You know, like you can't break the law. I can't change the laws of physics, Captain, right? The more I study engineering and the more I understand it, the more I don't necessarily think of physics like as something that's going to constrict you. All right. I think of physics as a guardrail on a highway. Okay. What does a guardrail do on a highway? Make sure you don't drive into the freaking woods, right? You can use that to your advantage if you're Ross Chastain. That's not everybody's going to get that joke. You don't consider the laws of physics being there as a way to constrict what you're trying to do. The laws of physics are there and they are inalienable laws, and you can use that to your advantage. Right? Like we know that if we make more upward force than the force of gravity, you know for a fact it's going to go up. There's no getting around that. If the thrust coming out of the rocket, the force coming out of the rocket is greater than the force of gravity, right? It's going to go up. There's no like interpretation there. It's going to go up. As long as you're pointed up, if you're pointed parallel to gravity, you make more force to the force of gravity, you're going to go up. That's what I mean. Like, you know that that's going to happen. There's no getting around that. Use that kind of stuff to your advantage, right? You can use the laws of physics as a way to, instead of using it as something that's going to constrict you, you can use it as something that's going to help you to make sure your stuff works correctly. Right? Yeah, I mean, thermo is a pain in the butt, Lava, but you know, see, like, that's the point that I'm trying to make. Thermodynamics is annoying, and it's really, really annoying that you're never going to be able to get 100% efficiency out of something. That really sucks, and it's really annoying, and it's very black-pilling, so to speak. But also at the same time, you know, you could sit there and you could say that thermo sucks. We're never going to, you know, it's never going to, you're never going to win, right? With thermodynamics. You're never going to win. You're just going to achieve a result. Or you could sit there and say that, look, I know that this is going to happen, so I'm going to use it to my advantage. Doing that is what, like what Jacob said, is stuff that makes this work. I mean, yeah, it is annoying everywhere. You ain't kidding.
All right, attention all B-19 operators. This is the final go, no-go poll for today's operations. Our main objective today is a 10-engine static fighter.
Perspective shift of a bug to a feature. If the laws are inalienable, Don, why try to push against them? Why not use them to your advantage? Right? Something to think about.
Static fire is the culmination of the engineering process.
Right? It's good stuff.
We're bringing all of the pieces of the puzzle together, and we're lighting the engines.
Hello.
And if you make it through that, you have pretty good confidence that you're in a good position to go fly.
Aboard.
Except if you hear that one.
One looks like we kicked out due to 2 combustors from the apex bank being pelted.
Looks like we got to engine time of 2.135 seconds.
We successfully lit all 10 engines. They were ramping up to power. Everything was looking good, stage and engines combined.
Nice, Tessa.
However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
Fast shutdown could potentially make engines angry. It could make them angry.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
So you see what I'm talking about there? There's the fruits of Raptor 3 is already paying dividends there. Did you see what he said? Oh, we think we may have damaged them. They're no good. Well, not they're no good. They're going to take them apart and to see what they damaged, right? And then instead of trying to repair it and put it back on, just take other engines that were destined for the next booster, put them on there, good to go. When you can manufacture a lot, you could beat it with you could beat the logistics problem of rockets with scale. That's why SpaceX has a couple of big gigantic rocket factories around, and why they're building more. You could beat this problem with scale. That's what we did with the airline industry. Yeah, I'm not doing that, Tessa.
All right, attention all operators on LVN-1. Today's main objective is a 33-engine static fire on B-19. Okay, go.
No, that's what he said a second ago. Listen. 1824.
And
result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
There you go. That's right, Buck.
All right, attention all operators on LVN-1. Today's main objective is a 33-engine static fire on B-19. Okay, go, no, go.
Can you explain why they aborted the 10 and 33 engine test later? The pad is not cooperating, Lev.
Coming up in 1 minute.
That's right, Six String.
so we're doing our static fire today with all 33
Probably
engines.
chaos, yeah. Depends on how much they're messed up.
This is the final go, no-go poll for today's operations. Flight software.
Go.
AY.
Go.
Raptor.
Go.
Stage.
Go.
CE.
Hang on.
Go.
I'm pausing. I haven't seen this shot before. Woof. Think it gets hot right here? It gets hot right here. Probably gets real hot. Jeez. Look at that damn thing, dude.
GC2.
Go.
GC1.
Go.
FC1.
Go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, mission.
Wow.
That's crazy. That's a lot of power, man. Dude, that's no joke. Holy crap, dude. Dude, I've seen the static fire before, but that thing is angy. There's a lot of spiciness coming out. Look at the size of that dang cloud, dude. Can I just want to see it again.
3, 2, mission.
Wow.
Yep. Shnikes.
We kicked out early. All teams triage alerts. Prepare for offload.
No good.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're gonna see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
Yeah.
I think every test is always a
Theoretical vibe.
success, and we had a bunch of findings on the ground systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
So you guys want to see something interesting? Look, if we go back to 2052 here. Use YouTube. Jesus Christ.
Then we're sabotaging our static fire today with all 33 engines.
This is the final go no go
So
hole.
watch. You can see the telemetry. They show it, but they only show it for a second. This is all the, you see like, you hear people talk about like, oh, bad sensors or weird data or anomalous data. That's what they're looking at. They're looking at this stuff right here. So watch. When ignition is commanded from the sequencer on the booster, watch. It's Charlie's desk, I believe. They show. All right, so see all the telemetry? That's all the data streams, or all the main data streams from different stuff, right? Watch when they command ignition. See? All the stuff starts to go up. No, it wasn't Charlie's desk. I don't know who it was. Why not just click download and play on your own player? Because the amount of time it would take to do, we could just watch the end of the video. Like, it was pretty much good up until now. So watch, they show the guy's desk again. It's not Charlie's desk, this dude, see? So there you go. They had to ramp up and then it ramped down. I don't know what these data streams are necessarily. Could be engines, could be water. It depends on what, I believe that gentleman's name is Pete, I think. Yeah, we'd have to go back and look. But look, this one did something different. See that? All these data streams go up and then they peak. That one peaked early and then it went down. See what I'm talking about? Now, once again, I don't know what any of that says. It's blurred. You can't see it. I will say that one is different than all the other ones. And that one up there, but that one is very intentionally different. See this one? That one's different. This is what potentially anomalous data looks like. Potentially. I'm not saying that that's what it is, but see how it's different? See how the lines are different? All of these are pretty much similar, which tells me that whatever this is, it's all more or less the same thing. But see how this one at the bottom is different? There you go. When they say stuff like, oh, I've seen out of family data, that means you see something that's different than the other ones. And it's going to take time to figure out what that is and why it did it. Now, I'm not saying that is what SpaceX found. Like they said the manifold pressure failed on the pad. I would say that's most likely the vehicle blew out the sensor, but who knows? That's Joe Peterzelka. Yeah, that's his name, Joe. Yeah, I got his last name mixed with first name. Well, you don't know if water is... See, okay, this is why this is a tough problem to figure out. Listen to what she says here.
Prepare for offload.
When they talk about what went wrong.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds.
So the ramp manifolds are the water pressure system that delivers water to the diverter that's down in the trench. They said they lost sensors. That doesn't necessarily mean that something is wrong, but it might mean that something is wrong. This is why when they say, oh, we got to analyze the data, you have to figure out did the rocket engine going off just blow out all your sensors? Or did some other effect cause a manifold drop in water pressure? You do not want to lose water pressure on this pad. You saw how violent that explosion was when it came out the sides. You don't want to lose water pressure. The second you lose water pressure is when the pad does a pad 1. And parts of the pad starts getting ejected out the sides. We don't want to do that. That's why the water system is kind of their kind of Achilles heel here, so to speak. It is a pad issue, absolutely. Now, it could be a pad telemetry issue, could be a bad sensor. It's possible. Could be a bad sensor. Maybe you did lose water. And if you lost water, that means the pad could be damaged. And worse, the engines could be damaged again. They lost water on the 10-engine static fire. And they self-admittedly said that they may have damaged the engines. Why even speculate? I'm not speculating to tell you guys what's going on. I'm speculating I'm not... No, Lava... All right. I'll just explain it to you. I'm showing people what fault tree analysis is here. I'm not trying to extrapolate anything particular from SpaceX. I know what happened. I know very well what happened. This is to show fault tree analysis and telemetry and how it works. Because this is not something that the plain Jane person watching this video might understand. They're just going to see a bunch of lines going up. I'm trying to explain what those lines do and why this is such a pain in the butt to try and figure out. That's rocket science, man. That's seemingly easy for you to understand, dude, right? Like, but I'm trying to keep it simple. Hey, John, watching on catch up. Okay. That's Joe P. He's the booster VP. Yeah. So this is what happens. And this is why when they show all the pictures of all the crews that are working on this, they're all like, because now you have to figure out, did you lose a sensor? Did the booster firing, did it blow out your sensors? Your sensors are giving you weird data. Remember, differential data streams, okay? If they're giving you weird data, is that a problem with the sensor or is it a problem with the pad? Did you actually lose water pressure? If you lost water pressure, right, even for a split second, right, what else did it damage? Because if you lose water, if you're losing pressure in the manifolds even for a split second with how violent this damn thing is, it's going to break something. It's going to either break itself or something around it. I mean, I don't know if you guys saw the amount of energy that came out of that booster in 1.8 seconds. It's no joke, right? This is mission control or launch control. This is how this works. Now you got to do what's called a fault tree analysis. And I'm willing to bet that they said that the sensors were weird, but then they immediately pulled the booster off the pad and put it back into the mega bay, which tells me that that may not have been. Now, this is the speculative part. I'll admit this is very speculative. That may not have been bad sensors. You may have lost water pressure. And if you lost water pressure, that probably broke something.
Basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're going to see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
I think every test is always a success, and we had a bunch of findings on the ground system.
Look at all of them. They're all like, oh no, what the heck? That's a hard problem to solve. Whether your sensors were lying to you, whether a vibration broke the sensor, whether you actually lost water manifold pressure, it's a tough problem to solve. Like look at her on the end. She does not look, that doesn't look happy. That's like a real freaking like humdinger of a problem. That's problem solving mode. That's like, oh crap, something went really wrong here. We don't know what it is. Is the booster autonomous on static fires? Absolutely. Now, the thing is I know, Rarest, you said they did a full tanking test before they pulled the booster. Who's to say that that tanking test wasn't part of the fault tree analysis here? Right? It's possible. Why would you test it after the static fire went this bad? Think about it, dude. Maybe that was trying to prove out some data. There might be a clue there if you're into doing the speculation thing. Everything happens for a reason. Everything is deliberate. There's no random failure here. No, it happens for a reason. Like I said, there's that's that physics thing that I'm telling you about. There's always a root cause. Always. They also did the random spray. Yeah, you see them test it. You saw them testing the deluge system a lot after the static fire. There you go.
Systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
I got you, Lava. Yeah, that's why I just explained it, dude. It's all good, man.
Yeah, we have the saying called
only
the paranoid survive.
We're good.
The idea behind it is that there's an enormous amount of information and data that's coming to you, and if you can use that wisely, you can usually use that to figure out like where things are going to go wrong in the future. And almost every time that we fail something or have something go awry, there were clues in previous data and previous operations that if you had known what to look for and had been good enough and paranoid enough to do so, could have found it there.
See that? That's it, man. leave nothing up to chance. Let that physics work for you. Don't try to work against it, because the second you try to work against it, you're not paranoid enough, it'll blow up in your face. This is 10 months before that static fire.
It's been 10 months since Massey's
Hey, you remember when I said it'll blow up in your face?
had the S-36 anomaly.
Oops.
Ship 36 was a tough one. We had a COPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
Dude, I actually haven't paused to look at this. That is hosed. The ship was on that mount right there. There is nothing left. So what happened with Massey's, guys, this Ship 36 static fire, those damn composite overwrap pressure vessels went wrong again. So, okay, remember how I said they were doing they do cryo testing with liquid nitrogen, right, to keep it safe. When you do a static fire, you got to put propellants on the vehicle. So what SpaceX does, and they still do this to this day, this was not the problem here. What SpaceX does is they fill up the entire liquid oxygen tank as ballast, and then put a tiny, teeny weeny little bit of fuel in there, just enough to get all the engines and the plumbing working for a small amount of time, and then they shut everything off. But that's the ideal. What happened here is that COPV popped, right? The methane immediately atomized with what liquid oxygen was there, made a nice explosion. But what took out the rest of the test stand was the tidal wave of liquid oxygen that splashed around the entirety of Massey's. Think about that, a tidal wave of liquid oxygen. Think like Terminator 2. I mean, that was liquid nitrogen, but you get the idea.
In 10 months since Massey's had the S-36 anomaly.
So it's very clear from where that explosion was that it was the COPVs. It was the COPVs that are in the payload bay. I pointed them out at the beginning of the video. They're by the transfer lines. It blew up, immediately ruptured the methane tank. The methane tank immediately ruptured the LOX tank, and there's your tidal wave of liquid oxygen right there. Now, all of the methane that was up there, all the methane that was in this rocket, it combined with as much liquid oxygen as it could and made a nice big explosion. But the majority of the pad gets hosed by a tidal wave of freaking LOX. See that? Oh, hello.
Ship 36.
So the thing about it is that oxygen in itself is not flammable. I know. Yeah, I said that. And people are going to be like, no. Yeah, it's not flammable by itself, but it combines with things and makes everything else more flammable a lot quicker. So basically, if you hose the entire pad down with liquid oxygen, you will not need much heat to make a nice big explosion. Just imagine if they put this on the pad. Well, yeah, paranoid survived, dude. That's why you put it on a test stand. So it's an oxidizer. It oxidizes things. If you add oxygen to anything, you can get anything to light on fire. Paint, metal. The metal becomes solid rocket fuel in this analogy. And that's what happened to most of the test stand. The most of the test stand became a hybrid rocket engine and ended up being solid rocket fuel, and that's what that secondary explosion was.
This was a tough one. We had a COPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
You see, there was test stand over here, but most of it just became solid rocket fuel when it got doused in liquid oxygen. All that over here. There's parts of the ship over there. There's parts of the ship in the woods. Yeah, that sucks. There's pieces of ship everywhere. I mean, this has all been fixed, guys. This was 10 months ago. But, yeah, that was a real big hit to the program. What blew up? That was Ship 36. Test stand-in. Hey, Zizep. You haven't seen this video yet. Oh. And then Red Panda had a raid that I missed. Hey, Red, how you doing? How many months since SpaceX made a flight? In October last year? November last year? It's not been long, comparatively. Yeah, you could see some of the vaporizers over there are still burning. You know why they're burning? Because the vaporizers get hot. And, yeah, what did I say? All you need, if you douse something in LOX, all you need is a little bit of heat to get it to blow up. And in this case, we had a tidal wave splash through the entire test stand. I'm actually surprised that, so over here is the water systems. Over there is fuel and stuff. I'm actually surprised that more of this didn't explode. It's pretty impressive.
Losing a rocket is one thing. We've got a production line for rockets, and we can go make more. Losing the physical infrastructure.
Yeah, see? There's a piece of the ship right there. Yeah, that's the downcomer right there. There's some pieces of the ship over there. Some tiles. There's tiles all over the place. You could see where some of the pad turned into solid rocket fuel. Some of it's still solid rocket fuel over there. Those are the pumps. That's the pump system right there. That's on fire.
The launch pad of the test site is...
Most of the ship found its way down into the flame diverter. Yeah. Yeah. Yeah, that's fine. Have you considered CI3F, the paragon of oxidizers? No. I'm just talking about LOX here. There's some pipes over there. What's the flash point of methyl oxide stoic? I have no idea. It's not a lot, though. Yeah, see, there's some plumbing from the ship. There's the test stand that got, part of the test stand gantry that got blown over. Yeah, most of the ship is just down there, though. There's some engines down there. I'm actually amazed that SpaceX showed a shot inside of the diverter. It took some balls to show that. They really don't usually like showing off this stuff.
Very difficult, because you need...
Yeah, see what I mean? Everything. You douse it in LOX, it just, everything turns into a, everything will catch on fire. Concrete will catch on fire. It's, well, maybe not concrete. To an extent, it probably ablated a little bit of it. Yeah, paint. Paint makes great fuel. Paint's oil-based, so that kind of paint is.
Need to go repair that over a period of minutes.
Woof. See that over there? That's the transfer tube. That got some distance, man. That got nice distance. Yeah, see? It burned. Yeah, it did. It burned the concrete right there. See that? Turned the concrete into solid rocket fuel. See, it's all charred away right there. Look at that. I'd never noticed that before. That's great. Not. I'm amazed this thing didn't light on fire, but I mean, it looks like it did to an extent. If it has carbon, it burns. Yeah, that's right. Yeah, see? That's a part of the ship over there.
Months before you can get back into testing.
Yeah, see, here we go. This was a little earlier.
Now we have Massey's back online here. We've really, built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new.
And this time they built the pad encased in, all the pad GSE is encased in concrete. Just in case. And they put all the pipes in the ground. Notice how there's no pipes running right here? They put it all underground for probably, that's probably a good reason why you did that.
Systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Static fire vehicle is in pre-pad clear, about to get to our static fire pad clear top state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle.
How long did it take to clean everything up? Ken's, that little maneuver cost them 10 months. Yeah, see, you could still see over there. See all the burned trees over there? Part of the ship found its way into the woods over there. See all, look, you could still see where the LOX tidal wave went. See it right there? It's a circle. Massey's is down the street from the pad, Farish. Yeah, I've been here. I haven't been to Massey's, but there's a road over there that I've been on. Yeah, this is the Rio Grande right here. That's Mexico. Right there. That's Mexico. This is the US, that's Mexico. Yeah, the river is the US state border.
Performance.
Or federal border.
That if you can make it through that you're in a reasonable position to go fly.
Yeah, see, that's Mexico over there. Hello.
Start up.
Throttle up.
Plus 10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
So these water tanks are dumping water into this right here, so you don't make a nice big hole in the ground any more than there already is. This is a diverter in a bucket. They basically pour a waterfall's worth of water in here, and that's what this big steam cloud is. The cool thing is that when the ship is firing, you could see the sound reverberates through the steam, and you could see the sound. It reverberates through the steam clouds. Watch. See it? Isn't that cool?
The impact that this rocket is going to have on the world, I don't think most people can really comprehend the change it's going to have.
This is such a wild ride. The highs are high, the lows are low, as we really work to get to ultimately launching people, which is going to be amazing.
Plus 40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.
Yeah, baby.
Plus 50.
Drop down and cut.
Full duration.
We do not tin it. Nice. And if you work down there, you know exactly what this is. They close the road, right? And then a traffic jam builds up behind the ships because the only access road into Star Factory and everything is Highway 4 here. It looks like they're going to build another lane here to avoid this exact problem. Did one of the center engines shut down, or did it run all six? Hard to tell. It looked like all six were working nice and healthy there. Let me take a look again. It's hard to see that one because one of the vacuum plumes is in the way. I've gotten stuck behind them, Coltec. It's pretty crazy. I don't work down there. Well, kind of do. But you get the idea. Flight 12 up next, or another static fire. Go Voyager, what do you think? The results of that test from the Booster 19 static fire were inconclusive. Would you try to fly? Something like that, cousin. No, you wouldn't. So, there's your answer. Are they going to launch Flight 12 before the IPO? I don't know.
Plus 50. Full duration.
So the idea here is that it really depends. I mean, if it was me, I would probably want to get more data on static firing and making sure your pad works, right? Yeah, I figure, you put the booster out there, you stack it, you might as well do a static fire before you put the ship on top of it, right? That makes sense. Which is what they might do. They might incorporate the static fire into their launch campaign. But it really depends on how well you understand whatever went wrong during the first 33 engine static fire. If you can conclusively say, and you can prove it with data, that you know exactly what went wrong and mitigate that problem, you might not have to. Think like Orion with the Artemis 2 heat shield. They did their homework. NASA did their homework, and they very well understood what was going on with the Artemis 2 heat shield, so they flew it on a different trajectory because they worked with the laws of physics instead of against them. And they were able to get Reed, Christina, Jeremy, and Victor back home. because of the good analysis. You do good enough analysis and you're paranoid enough, like what Charlie said, you can basically predict the future with outcomes here. Problem is that that's hard to do. I thought they said it was the sensors. They said the sensors were giving them a bad reading. Whether that's the sensors actually giving them a bad reading or the sensors themselves breaking is another story. Pretty cool. So we'll keep up with this mini-series as they release more. That was SpaceX's test like you fly. That's good stuff, man. It's a great video. Good stuff, dude. Dude, there was a lot of cool stuff in that all at once. I think my favorite shots were the thermal protection systems, like at the beginning of the video. Also, the welding jig to make the grid fin. That's pretty damn cool. I want to go over here. Oh, hello. I'm sorry, that's just damn cool. Do you think they will build a refurbishment hangar by the launch pad? Gigabay, dude. That's what the Gigabay is for. Yep, there it goes. Did anybody test like the functionality of this video player, or did we just kind of wing it? Like, just honest question. I mean, I'm not entirely sure that this is on my end. I'm pretty sure this happens to other people. I mean, test as you fly applies to software. Just saying. You can download the video. Yeah, I'm aware. I'm not talking about the video. I'm talking about the player, though. Rockets have to take that road every time. Tanit, there's only one way to get in there. It's Highway 4. Highway 4 is the only way down there. I'll show you. So Starbase is at the very southern tip of Texas here. It's down here. It's in what's called the RGV, the Rio Grande Valley. So this is Highway 4 right here. Highway 4 connects into Brownsville over here. It goes by the airport too, which is nice. There's Brownsville over there. And then, yeah, if you follow Highway 4, you go a little ways down here, you get to Massey's. This is the Massey's test site. The reason why it's called Massey's is because before it was Massey's, before it was the SpaceX test site, this was a gun range, Massey's gun range. So they named it after the guy, the gun range. This is an old picture. That whole flame diverter and everything is right here. Yeah, that's a super old picture, by the way. Massey's connects into Highway 4 over here. And if you go down Highway 4, it'll eventually get you to Starbase. And if you want, there's the 2 megabays, and the gigabay is not even in this picture yet. It's right here. They have to move the ships down here out this way. But if there's a ship that is moving to Massey's or a booster that's moving to Massey's, that's the only way. So you get stuck in a traffic jam. I think they're making the road 2 lanes. If you look, you can kind of see. Like, this is an old picture, right? But if you look right here, and then you look at this picture right there, you can clearly see that they're grading out terrain over there for another road. Let's go to the very end. See what I mean? They're gonna make the road double wide, and they're gonna do that on purpose. But yeah, and if you want to move stuff to the pad, you have to go this way. You take a left out of here, and then you go down here, down this road. This is still Highway 4, and then here's your pads. Once again, these are way old pictures. These are ancient in SpaceX terms. This is from April of 2024. That pad is no longer there. Pad B, the other pad, is right here. The one that they were doing all the testing on. It's right there. You could still see the suborbital pads here. These are the old test stands before they built Massey's. They used to test the ships out here. But these test stands are basically a stool that the ship stood on, and they're very inadequate to do full duration testing. Yes, but 5 launches per day won't be doable via that road. Says who? Why not? What's the problem here? You want to do 5 launches per day. You get 5 ships ready, roll them all to the pad in the morning, and then do 5 launches. Just stage them right here. I don't understand. I mean, Tanit, the other thing to take into account is that this is not the only Starship pad. Doing 5 launches per day helps if you have more pads. Well, what if one explodes and damages the rest? Only the paranoid survive, homie. I wouldn't get into launch operations if I was SpaceX if you weren't sure that the pad was going to work. That's what the first pad was about. That's what pad 1 was about, dude. It puts an hour in place. I'm no expert. I know the booster in this ship would fly. So, an hour. There's 24 of those in a day. Janet, they'll use other pads. That's what I'm trying to tell you. But the moving the ships around is not the bottleneck here. That's the easy part. And we saw from the Falcon Heavy launch this morning that most of this is finished, which is pretty crazy. You're paranoid. That's not what they mean when they say only the paranoid survive. That's not what that means. If you're worried about your launch pad blowing up during a launch, that means your launch pad is not engineered correctly or you don't understand how it works. I sure hope you're using iterative testing there, man. I mean, there's always unknown unknowns, but the whole point is to not have as many of those as you can, and that's why we have test stands. When do you think the first humans will be on Starship? If you asked me a little while ago, Mustard, I probably would have said 2028, but I don't know, it's hard to say. I think people launching on Starship, I mean, people are going to be on Starship in 2028 for a lunar landing, but that's not including launch operations. I think SpaceX will do what they did with Falcon 9. They won't even bother trying to, well, not bother, that's not the right way to say it. They won't even put humans on it until they have a lot of flights under your belt. You want to retire as much risk as possible, right? 2027 for Artemis 3 and Leo. Yeah, that too. But that's that's right. That is right. But we're talking about like launch operations here, right? Like you know, with launch operations, like somebody getting in to the Starship and launching from the pad. I don't think, I'm pretty sure that was the gist of that question, right? Yeah, I'm not sure. I would say probably, I would have said 2028 a little while back, but SpaceX did kind of pause and retool for Block 3. So I have to manage, we'll say manage expectations here. I would say most likely 2029, 2030, something like that. I would have SpaceX pursue the human rating. I think SpaceX will pursue human rating Starship after it lands people on the moon. I would not trust Starship to land with humans in it at all. Why? Why not? See, this is what I mean about physics. You're thinking the physics is going to punish you, and you're thinking the booster might blow up. I'm thinking, look, they've shown that they can do the flip and burn. That's actually one of the easier parts. They just said that in the video. They tested the ship first to make sure that that could work, because if that doesn't work, then the whole program's a wash, right? So I think that I think that it'll land just fine. On Earth, it just seems terrifying. Is it worth the risk? As opposed to what, Mustard? Is it worth the risk? Well, yeah, of course. It's worth the risk because what else can do what Starship can do? Orion can. And I would make a, if you want to make the argument that other avenues of getting back down to the surface from the coming back from the moon should exist, I agree. Hey, Vulcan, 76-month resub. I got to take pictures of something that's going to land on the freaking moon this week. Let's take a look. Endurance is going through a variety of tests ahead of launch in Florida. First one complete, modal testing. Very nice. We use sensors to measure how the lunar lander will respond to launch conditions. Tests were performed with Endurance mounted on the New Glenn Flight Launch Vehicle Separation System, LVSS, and a GS2 payload adapter. Oh, very nice. Oh, very nice. Very good. The moon landing will be easier because of gravity, surely. Interesting. It's very cool to be in the same room as this. Yeah, it's neat, dude. Got to get that GS2 stuff figured out, though. But, yeah, I want this thing to work. I want to see that damn thing on the moon. I don't want to see it spinning out of control. You know? But, yeah, it's pretty awesome. It's pretty good stuff. You and everyone else here. No, I'm pretty sure people understand the stakes involved. But, yeah, got to get that stuff figured out, man. I'm not trying to hate on Starship, guys. I just want to be 100% good until they use it. Well, yeah, that's why they're probably good. That's why they're landing people first, dude, on the moon, and they'll bring people. Like I said, that's what I mean by 2028 to 2030. for the whole put people on it and send them into space thing. You know, that's probably not going to happen for a little bit. The thing is huge up close. Yeah, I can see that, dude. I see the person over in the corner over there. Nice. Very nice. Very nice, dude. That's great. Good picture. All right. E. I just think it's harder to de-risk lunar landings. It's harder to de-risk lunar landings than Earth landings. Yeah. Yeah. I mean, probably, but they're going to de-risk lunar landings first. Ugh. Sorry, guys. I'm yawning like crazy all of a sudden. I'm going to probably get up and stretch while I jog the VOD here. Do I have any more coffee left? We do. Oh, package shipped. Very nice. Time for a coffee? Well, I just had some. You just burnt your tongue. You guys stop making me yawn. You do this, I swear. Somebody yawns and then it makes me yawn. It's like humans can sense it through the computer. This is your fault. This is your fault. Will there be an uncrewed landing on the moon? I thought 3 is LEO docking and 4 is the actual crewed landing. Per NASA's requirements for the contract session, they have to do an uncrewed landing. My personal theory is that the whatever lander they used to demo Artemis 3, they're going to probably send out to the moon. SpaceX or Blue. They'll probably send it out to the moon. It's there. Might as well. Why are you doing this? Stop it. Stop making me yawn. All right, anyway. So that was the SpaceX test as you fly, or test like you fly. That's going to be, they're going to do a mini series, they were saying. So, yeah, every time these videos come out, we'll do kind of a deep dive into it, which is pretty cool. All right, what do we want to do next? We've been kind of doing space news for like 4 hours now. I think KSP would be a pretty cool thing to do. We could do that. You know what I want to do? I kind of want to fly around the Endurance some more. Build some rockets. You may have started that. You yawned first. Look at your last comment. Blue tweeted a new post. Okay. Is it the one that I just showed on stream? That my buddy took a picture of? My buddy took that photo. Call your dentist. Oh, Blackness, yeah, I got a big problem with that. This, I really shouldn't reschedule again. This dentist appointment has been rescheduled twice. First dentist appointment was supposed to be April 7th. Second one was supposed to be April 19th. Nope. I really can't reschedule it again. Unless they want to hate me. Yeah, not great, dude. I've had a temp filling in here for like way longer than a temp filling. I really, really can't. I really can't reschedule it, man. Which kind of sucks, but yeah, Falcon Heavy scrubbing today kind of screwed me, but 2027 for uncrewed moon landing doesn't seem realistic. Yeah, I mean, you can say that, Max. Like that's the thing, dude. You could sit here and say, "Oh, no, that doesn't seem realistic." Well, yeah, I mean, they really don't have a choice. You have to because you're landing in 2028. So you could sit here and be like, "Well, that doesn't seem realistic. That doesn't seem realistic." Yeah, all right, great, good. So make it realistic because you have a deadline. You have a deadline that you said you would do. So make it realistic. Oh, that's still, yeah. I've had a temp filling for like way longer than I should, dude. I have to. I don't want to miss Falcon Heavy, but they scheduled, dude. If it was any other time in that day, if it was 11 o'clock, then I could do it. But yeah, 10 o'clock is right. That's when my dentist appointment is, which sucks. I can't keep a temp filling in here for much longer. It's starting to taste awful. Let me put it that way. Just do the stream from the dental chair. You know what? If they let me, I absolutely would. So, yeah, unfortunately, I'm going to have to miss Falcon Heavy. I don't want to, but yeah, we got to, dude. It sucks. Unless it scrubs again, in which case I'm great. Yeah. You know, ask the dentist to put NSF on the TV while you get the work done. I'll probably have my phone like this when I'm in the dentist chair watching the launch. I'm not going to lie to you. The dentist already knows I'm weird. He wouldn't think much of it. So, all right, guys. I'm going to take a second here. We have Tang tools. Let's break in a pair of pliers. That I don't need a tooth pulled, man. Anyway, so I'm going to take a quick break here on the Twitch side of things. And YouTube, I'm going to jog the VOD again. I'm just going to go outside for a second, dude, because all of a sudden I get really tired. I'm just going to go get up and move around. I will be back probably in like, I don't know, 15 minutes, something like that. And then we've already done a good plethora of space news today, so it might be better to just play Kerbal for the rest of the night. I don't know what we're going to do. What is this outside thing you speak of? I don't worry about it. Don't worry. That's not your problem. It's mine. New blue post. Yeah, we've seen it. All right. I will be back momentarily here. New career, go. What about the old one? You're going to start another damn career? He's a pilot of the ship that carries the boosters down the river. Blasting guy. Yeah, whatever. New mission mode, go. Oh, jeez. Let me finish the current projects that I'm working on, and then we'll do that. Maybe we work on the shuttle today. I think the shuttle might be a good idea. I want to finish that gantry crane, see if we can pull that thing up. Or we can finish working on SLS. We got our Ares 1 working really well. You'd like to see the shuttle pad work? Yeah, especially after we kind of proved that it could work. Plethora. Yeah, a plethora of piñatas. All right. I'll be back. When I get back, we'll Kerbal shuttle pad it up, I think. Let's work on the shuttle pad, and we'll go from there. I'll be back in a moment. Stand by for loss of signal on YouTube, as expected. I will be back in, I don't know, give me like 15 minutes. And then we go.